All right, this is part 3 of the Unit 2 review, which will be over key features of absolute value functions. So the main thing we need to remember is the main equation so that we can remember all the transformations that happen with absolute value functions. So the first letter we have here is A. A reflects the graph anytime this number, what in front of the A, is negative. So we can notice right here in this problem, see how that's negative in front of there? That means we already know that it's going to be a V that's going to be pointing down. So knowing these things really helps us predict how the equation is going to look, how the graph is going to look. The other thing that A does is it can vertically stretch or compress, which means that it's going to get skinnier if it's stretching or wider if it's compressing. If you think about stretching a rubber band, it gets skinnier versus if I compress it down, it's going to get wider. So anytime it is a number that is not a fraction, like 2, that is going to stretch it by 2. It's kind of like a multiplier. If I multiply it by 2, it's going to get bigger. Versus if I multiply it by a half, that number is going to get, a wider graph. That's going to compress it. All right, the B right here does the same thing except it horizontally stretches and compresses. So it's stretching and compressing the other way. It's going to have the same effect on the graph in the end, but it's stretching the opposite of the A. H is the one that's going to shift it left or right. And we always want to remember, because of that minus sign right there, it's always going to do the opposite of what sign it says. So if it says -2, that means it's going to go to the right. If it says +2, that means it's going to go to the left. It's always the opposite. The K is our last transformation, and the K shifts the graph up or down. And so if it says +2, we know the graph's going to be shifted up 2. If it says negative, it's going to be shifted down. The H and K are also always helpful to note that they are going to be our vertex. The vertex is a very key point when we're graphing absolute value functions. So, for example, looking at these two numbers, my vertex is going to be at 1, 3. That's where my vertex is going to be. I can already tell without even putting it in the calculator that that's what it's going to look like. I also know by looking at this equation it's going to be reflected because of that negative, and it's going to be stretched because of that 2. So it's going to be stretched down by 2, like that. Now you can put this into the y equals of your calculator to verify that that's what the graph looks like, but get in the habit of starting to recognize what transformations should be happening based at just looking at the equation, because it'll make you better, and we're going to be doing these transformations all year. So it's really helpful to learn what each of these letters do. All right, now that we've talked about the transformations, let's look at this one to see if we can identify what the transformations are. So anytime we are talking about what changed, what's different, we are always comparing it to this parent function. The parent function here is f of x, or y, equals absolute value of x. That's what we're always comparing it to. So we're looking at g of x down here and asking, well, what transformations have taken place? What is different? Well, first off, I can tell that the vertex has shifted to the left 3. I can tell that the vertex has shifted down 1. And the last thing, the most noticeable one, is it's flipped down. And the word we use for that is reflected. That's the math word we're using, reflected. So those are the 3 transformations that we have for this graph. The next question says, where is the vertex? Well, the vertex, we can see, it's this point right here, which is at -3, -1. And since it's the very highest point, we know it is a maximum vertex. What quadrant is the graph in? Well, if this is quadrant 1, and this is quadrant 2, and this is quadrant 3, and this is quadrant 4, we can see that the graph is in quadrant 3. All right, the last one I wanted to do with you kind of brings it together and bringing back domain and range. So first, let's talk about the domain. They want us to do it in set notation. Remember that set notation is the one with the curly brackets, and since we're talking about domain, that's the x values. So we're asking how far left and how far right does this graph go? Well, it's going to keep going to the left to negative infinity, and it's going to keep going right to positive infinity. All right, how about the range? The range as an interval notation, that's the one with the brackets and the parentheses. We have to really start remembering those names. So the range is asking how low does this graph go to how high. Well, the lowest point on the graph is -2, and it is equal to -2. There's not an open circle there, and it's not an infinity, so it's equal to. The highest the graph goes, well, this is going to keep going and going and going, so that is infinity. And remember, we can never be equal to infinity, so I need a parentheses there. All right, again, where is the vertex? Well, that's this point right here. In this case, it's 3, -2, and it is a minimum vertex because it's the very lowest point. The axis of symmetry is going to be where, if we were going to cut this graph in half, and it was going to be symmetric on both sides, where is it going to hit the x-axis? Well, it's going to hit it at 3. Be sure you write it to like an equation with an x equals, because it's actually the equation of that line. X-intercepts. Well, where does it intercept the x-axis? It intercepts the x-axis here at 4, and it intercepts it at 2. I'm going to write it as an order pair. So 4, 0 is one x-intercept, and 2, 0 is the other x-intercept. So that is the features of absolute value functions. Just remember, you make sure you know all those vocabulary words and you know how to put the graph into your calculator. One little note, just in case you don't remember, to get it on your calculator, you go to Math, and then you arrow over once to Num, and the first option is abs. That's how you put it into your calculator in case you forgot. That's how you get the absolute value bars in your y equals.